Hi all, Raul Klingberg here. I thought I'd walk you through some of the tests that we ran recently at Marina Beach with the extended Elevons. I'm going to talk a little bit before each segment and then let you watch it. This first segment is a view from the front, obviously, and give you a look at the new roll rates. Now, unfortunately, I can't find the video from the old roll rate tests, but this is about double. And what I want you to note is that the roll rates here are not as high as what I would expect in flight because the wheels are on the ground, and that provides resistance. In fact, there'd be points where you see the wheel pick up off the ground, and it distinctly slows up the roll rate. Plus, there's a different roll rate right to left and left to right. Why that is, well, we're on a slope, there's a couple other things going on, a little trim condition, but overall I'm very happy with these new roll rates. I was able to calculate in the mid-range something around 7.5 degrees per second, which I think is probably about half of what it will achieve in flight. 15 degrees per second would be great, and let's take a look at it. Oh, I almost forgot to mention, these tests are done with the smaller Elevon extensions. We've already cut off about half of their span, so the roll rate here is a little less than what we expect in the final configuration. In addition to, these Elevons have a smaller chord than the final configuration, so I would expect significantly more rolling rate for that final configuration. I think we're going to be great for the next set of test flights. Here we're looking straight down at the wing from the top of the winglet so that we can see both the inboard and outboard portions of the wing relative to the winglet, and we get to look at all the tufts that are there. This is a series of JPEGs so that we essentially have stop action, and so I could pick out any single JPEG and look at the flow conditions if I wanted. You get a good view of what the Elevon extension is like here. It's just tacked onto the trailing edge. There's my buddy Dave. And actually, the Elevon extensions will be further forward. The hinge line will be lined up with the inboard set, and so the chord is going to be quite a bit bigger, at least like 30-40% larger on the final version, which will be good. So basically what we're seeing here is really good flow conditions, both inboard and outboard. Inboard looks fabulous. Everything's nice and straight, well attached, just like we want. You'll see the last two tufts on the outboard Elevon, the Elevon extension. In the large down deflections, you'll see separated flow there. And I suspect we might see some of that go away when it's actually not hanging off the trailing edge of the wingtip. When it's up in line with the rest of the Elevon and we have the wingtip acting as a block with its tip vortices, we might actually see some reduction in that separation of flow off the tip of the Elevon, I hope. If not, might have to put a little end plate on it. But overall, the flow conditions look very good. I'm quite happy with them, and I think we're probably good to go. And so what we did here was just a series of deflection excursions where we could take a look at the flow conditions, both for full down Elevon and full up Elevon. I was particularly worried about full up Elevon causing a lot of span-wise flow. It's a situation that I had occur on my original wing, but we're not seeing much of that here. And I got some video coming later of different Elevon shapes, and we're going to have a chance to talk about that and some of the interesting results that we got. So we'll just let the rest of this run out. Here we have the top view again, and this time you see that I've cut the span of the Elevon in half, and we're now testing what the roll rate is like in that configuration. And we see that what I saw is the roll rate was a little reduced, but not significantly. The most important thing to note is we're seeing span-wise flow on the Elevon and the down deflection at its tip again, like when it was longer. And these tufts before, when it was longer, weren't going span-wise, so it is an end effect. Now we're going to run a movie here, shot from the same location, top of the winglet looking down. This is the longer span Elevon, so earlier in the test, and I got this set up so you can get a view of me handling the glider in the pilot's cage. And unless I miss my guess, we're going to do a fast walk down the sand dune here. The wind's blowing about 15, 17 miles an hour, so if we walk at 3, we're very close to stall speed, and about 17 miles an hour the glider carries its own weight. So I didn't need to strap in or anything, just pick it up and walk it down the sand dune, and we're flying at stall speed. And you'll see a series of pitch excursions, I believe. It's not that the glider is unstable. I'm actually commanding the pitch excursions, and this was after I had shortened the throw on the elevator control horn in the mixer to reduce the amount of elevator throw. It was a little touchy at first, and then made adjustments and it's much better, and I was able to accurately point the nose up and down. The excursions are going exactly as I'm commanding them, and we should, as soon as I start walking, you'll begin to see those. It'll look kind of weird from this angle because we're looking straight down from a 360-degree view camera, so it's a little bizarre, but you'll see it here. You'll have a feeling of going up and down. There we go. Nose up, nose down, up. And it looks like we're kind of bouncing up and down. But those are pitch excursions that I'm commanding. I had very good control over them. There was no problem with those whatsoever. And I was very happy with those results. And I felt that I had much more precise control over the glider, both in pitch and roll. So, all's good. This is a rerun of the same test. I've slewed the camera software a little bit so you can see the entire wing. I thought I'd give you a little better view of those pitch excursions. For this final chunk of the video, we're going to look at 3 different Elevon shapes. I made full-size copies of the wingtip panel out of foam core board, so they're flat plate airfoils, and set them up with 3 different planform shapes for the Elevon. This first one is standard tapered Elevon, where it's a little bit larger at the root and a little bit smaller at the tip, but it is a constant percentage of chord. This one is set up to be about 20% of the chord, so it is wider at the root than at the tip. We're going to look at the flow conditions for various deflections. The wingtip will be a very messed up flow because my buddy Dave's foot is standing on the front of it, so it doesn't get away from us. It's up on sawhorses, and I'm at the other end manipulating the Elevon. And when we get down to the final shape, we're also going to look at a constant chord Elevon. That's about 25% of chord, and then about 30 some odd percent of chord out at the tip, but it's the same width all the way along. And then we're going to look at a highly reversed tapered Elevon at the end. Then we're going to do a little chalk talk about the very fascinating results that we got. So let's take a look at this first constant percentage of chord Elevon. So one of the first things that you're going to see here is when the Elevon is deflected down, there it is right there, all that huge span-wise flow, that is separated flow at a very small deflection. In fact, we know that that occurs at about 15 degrees. You deflect that Elevon down 15 degrees and out they go span-wise. And then as it's deflected up, you'll see some span-wise flow developing about mid-span on the Elevon, and then getting pretty severe out at the tip. And neither one of those are good. We don't like to see that. That span-wise flow will put a shear into the boundary layer and cause premature separation of the boundary layer and stall the wing. So the first conclusion here, pretty easy to reach, is that constant percentage of chord Elevons on flying wings are bad. I would not ever recommend them. And based on many flying wing models that I've done, I've been through the strip Elevons and the standard taper ones like this, and those models had nasty tendency to spin. So what is essentially a common Elevon configuration is not good for flying wings. Here we are, we're looking at the constant chord Elevon, and we see that there's only minor differences. I can deflect it down a little bit further before the flow starts to separate, and it separates first out at the tip, but not much after that the root separates also. It's a little better on the upside. We can see here the flow is not going quite as span-wise out at the tip. And there's a reason for that. We're going to discuss that later. And that slight difference can make all the difference on a model. A model that has barn door or constant chord Elevons is often much more spin resistant. And it took me a while to sort this out in my brain as to why this happens. And you might be a little bit surprised when I'm done, but when I tell it to people the first time, they go, "Oh yeah, that's right, I forgot about that." It's one of those things that we hardly ever think about, but if you stick around to the end, you'll see the explanation. Now we're going to look at the Elevon that has a significant reverse taper. The root end is about 10% of chord, and the tip end is about 70% of chord. In fact, the hinge line runs all the way up to where the spar would be. Excuse me. And we're going to see some very significant differences here. Keep in mind that the flow at the tip is getting a little bit messed up because of the leading edge area, but we're going to see some pretty significant differences between the root area and the tip area in terms of flow attachment. And that'll start any moment here now. Here we go. And I want you to note the difference between the root and the tip ends as I deflect it down. There, the root end is separated, but the tip is still flying. Disorganized flow, whipping around, but still attached. We'll do that one more time here. Let's deflect it down, and there goes the root, but the tip is still flying. And that's quite a drastic difference, because that is not what happened on the other Elevons at all. We generally got separated flow at the same angle. In fact, I have to deflect the Elevon down an additional, about 10 degrees. I have to go to about 25, 27 degrees to get the flow to separate out at the tip. So it is a big, big difference. And this is a big plus for flying wings. If we can keep that flow going straight, so much the better. And even when it's deflected up, the flow is doing better than it did with the other Elevons. We're still seeing a little bit of spanwise flow out at the tip, but that is deflected way up. We're looking at 35 plus degrees of deflection, and the air is going up over that Elevon shape. So a little bit of spanwise flow there, but not too bad. Not like the 90 degrees we saw in the other versions. So this is a significant improvement, and we're going to have a little chalk talk here in a bit about why it is. Here I thought I'd throw in a little bit of bonus footage at the end. This is just shot from the rear. Dave is using a handheld camera to do this, and we're looking at the flow conditions on both inboard and outboard near the winglet. Winglet's wobbling a lot because it has a big mass on top of it, called my camera. There, you see it there. But overall, we're looking at flow that's very nicely attached and behaved. This is the Elevon extension that's the full length, as opposed to the one that I cut in half. And you'll see some excursions here where I'm doing full deflections, and we're getting fairly well behaved tufts everywhere, which is a big plus. And I think that with the slight reverse taper on the Elevon and the extensions, I'm going to have both excellent control and still have strong spin resistance. At least that's my hope. And right now it looks like it should behave that way, especially when I get the Elevon embedded up in the wing like it's supposed to be, instead of hanging off the trailing edge. And Dave will walk around the front here in a second. You'll see the roll rates from in front, and maybe you do your own comparison. You can look at the footage that we had up front of the half-size Elevon extension compared to the full-size, and see how the roll rate's just a little bit faster with the larger Elevons, as one would expect. That's a pretty good shot of the front of the wing there. I got the easy job. I just sit down and move the stick around. Dave does all the walking and video shooting. So, hey, but that's what good help is for. And there we can see some of the roll rate. You see the roll rate's really quite acceptable. I think it's just fine. As good as I had on my original wing. I think everything's going to be peachy. And now that I've said so many times I think it's going to be great, I've probably cursed myself. But anyway, keep your fingers crossed. And there we go. We get down to the end. Stick around for the chalk talk. We'll see you then.